Unit 43, shower pan or safe. For each shower pan size listed, there's 4 things that we're going to do. A, draw a dimensional sketch of the completed pan and plan and label the dimensions. B, draw a dimensional sketch out and label the dimensions. C, compute the area of the stretch out in square feet. I'm going to highlight this right now because this is going to be important for us. And part D is compute the total weight of the lead sheet using the thickness given. So first of all, your dimensional sketch. If you open your book, obviously they're going to be better artists than me, but what we're doing is we're drawing a 3-dimensional shower pan, and I always start by drawing the front face, and then go back. Again, I'm not an artist, but it's not too bad. And if you wanted to make it look a little more 3D, you can kind of add in those back pieces. Okay, so it said to label the dimensions. So we have 4 inches as the depth. So this is 4 inches. It's 40 inches by 32. And just the way that I drew my picture, I feel like this dimension looks more like 32. And this dimension looks more like 40. This is a shower pan, so it's not going to have a lid to this box. It's just the bottom floor and then the 4 side walls. Now, in your book, it explains this, but it doesn't say it on this assignment. But we are going to have what's called envelope corners. And what that means is that on your side walls, they're overlapping each other. So I'm going to draw the dimensional stretch out sketch next, and we'll talk just a little bit more about it. So if I have my floor, here's my floor, and we were told the floor was 40 by 32, and it kind of looks like that's the longer side, so I'm going to say 40 by 32. Now visualize for a minute that your side walls are all going to be folded flat down. So if I fold flat down, I'm going to kind of get this wall, this wall, this wall, this wall. But I introduced the word a minute ago, envelope corners. What's happening is these corners of material are actually still there. And so when you fold up your side walls, you've kind of got some overlapping material that folds over. This actually makes the box easier to make because there's less cuts. And so what's going to happen is we know that the height of our shower pan walls are 4 inches. So I'm going to label those on here. That means that this piece is 4 inches. That means this piece is 4 inches. And so this total distance all the way across is going to be 4 plus 40 plus 4, which is going to give us 48 inches. And then same thing goes for the other direction. This would be 4 inches. This would be 4 inches because the wall heights are 4 inches. So this total length would be 4 plus 32 plus 4, which is 40 inches. So if our shower pan was laid out flat with the walls down, it would be a piece of lead sheet that is 48 inches by 40 inches. So we've done part A, we've done part B. We're on to part C where it says to compute the area of the stretch out. Now the box for the area didn't give us much room, so I'm going to kind of be like going up and around, but we know that's what we're finding. So for our area, we're trying to figure out how much we need total. Well, this isn't really too bad because here's our sheet, and our sheet is 48 by 40. So our area is 48 by 40 and 48 by 40. Remember, these are both in inches, 48 inches by 40 inches. So in my calculator, if I multiply 48 by 40, I'm going to get 1920. And these are both in inches, so we have inches squared. Now, if you have your construction calculator, this is super, super easy because literally you type 1920 inches squared and then convert feet, and it will convert it for you. If you don't have a construction calculator, you've got to convert it on your own. So I'm just going to write this so you know what I'm doing. Convert to square feet. Well, if you were to convert the amount of inches to feet, you would have to divide by 12. We're not just converting inches to feet, we're converting inches squared to feet. So we're going to have to divide by 12 twice. Again, to convert inches to feet, you would divide the number by 12. But because we're doing square inches to square feet, we've got to divide by it twice. So I'm going to take 1920 and I'm going to divide it by 12, get the answer, and then I'm going to divide by 12 and get the answer. And I'm getting about 13.3. So this right here is our area, 13.3 feet squared. Now they're telling us that on part D, to compute the total weight, they're saying that for every square foot, I'm going to highlight it in green right here, for every square foot that you need, it's going to weigh 5 pounds. Well, we don't have just 1 pound, we have 13.3 pounds. So what we need to do is we need to take 13.3 square feet, and we need to multiply by 5 pounds per square foot. And what happens if you were to multiply is the feet squared and the feet squared cancel. So really you're doing 13.3 times 5. 13.3 times 5. And I'm getting 66.5. And the only units we have left are pounds. So this shower pan will weigh 66.5 pounds. Again, in your book they have examples of this as well. This is just a video version that will kind of help show you color and voice. Okay, the next chapter is Unit 45. We are skipping Unit 44. Yay. The only difference with this one is we're not doing a shower pan. We're going to have cylinder-shaped objects here. And for whatever reason, a lot of people forget what a cylinder is. Cylinder has a circle on top, circle on bottom. Those circles are the exact same size. That means they have the same radius, they have the same diameter, they have the same circumference. And they're a certain distance apart. So if I connect these circles, that is called our height. The distance that's between the top circle and the bottom circle. Okay, let's review a couple more parts. The radius goes from the center of a circle to an edge. That is your radius. The diameter is two radiuses put together. So if I go center of the circle and I go all the way across, that is the diameter. Now, there's two things that are going to be important to us. We have the circumference of a circle and we have the area of the circle. So looking right here, I'm going to use yellow. If you go around the circle, that's like the perimeter. For circles, we call that the circumference. So I'm going to write over here circumference. And that is around the circle. It's like the perimeter. And the formula for circumference is circumference equals pi times by diameter. And the other thing is sometimes we want to know what's the area. So area would be like all the inside. So for example, if I colored in this whole circle, that would be the area. The formula for area of a circle, area is the inside. Area equals pi times radius squared. And remember that if you square something, like say 5 squared, that means 5 times 5. Some people do 5 plus 5 or 5 times 2. No. Squared means whatever the number is, times it by itself. So here we go. Part A, make a dimensional sketch of the completed job. So, right here I'm just going to read the details. We have a 6-inch diameter tube. It's 20 inches high. And it's sitting on top of a square plate, 18 by 18. Well, I'm first going to start out by drawing the cylinder. So, visualize a cylinder for a minute. You've got your circle top. It's kind of looking like this, circle bottom. And it says that it's sitting on top of a square plate. Mine looks a little rectangular-ish, but you know what I mean. They tell us that the cylinder has a 6-inch diameter tube. They tell us that it is 20 inches tall. And they tell us that this plate is 18 inches by 18 inches. Okay, one thing that you need to know is that on the plate, this plate is square, there is a whole circle cut out where that cylinder or tube is sitting on top. So I'm going to kind of skip all the way over to the dimensions stretch out of the bottom just to kind of explain that. So you've got your square base, 18 inches by 18 inches. But what's happening is where that cylinder is sitting on top, this is a hole. So that's literally, you could stick your hand through it. That's a hole. And we know that that hole has a 6-inch, so from here to here is 6-inch diameter. And that is actually the stretch out of the bottom. Now, for the stretch out of the tube, I need you to visualize for a minute because you can't see me doing this, but hold out a piece of paper. It is a rectangle. Now, if you were to roll that piece of paper up, it would make a cylinder. So what I'm doing with my paper in my hand right now is I'm rolling it up so that the one end of the side of the paper and the other side of the paper are connected. It makes the cylinder. Well, around the top of the cylinder, around would be the circumference. And so if I unroll that paper, that's how long the paper is. So I'm going to try and draw you a little picture here now. Here's a rectangle. If I was to roll this rectangle up, it would look like our tube or our cylinder. We know that it's 20 inches tall. We're trying to figure out, well, what is this? Well, that's technically your circumference. And the reason that it's your circumference is because if you roll it together, it makes around the circle. So let's calculate for the circumference. Circumference equals pi times our diameter, which was 6 inches. So in my calculator, pi is 3.14 times my diameter, which is 6 inches. And I'm getting 18.84 inches. So that means that is how big or how wide that rectangle is, which is also the circumference. So our job now is to figure out the area of each piece. Well, the area of what we just calculated is really easy because when you unroll that cylinder, it's just making a rectangle. And the area of a rectangle is just length times width. So area equals length, 20 inches, times width, 18.84 inches. So in my calculator, I'm going to calculate 20 times 18.84, and I get 376.8 inches squared. That's the area for just the tube. Now, the next thing we got to do is the area for the square plate. Well, I'm going to do it in two sections. I'm first going to figure out what the square is. So our square is super easy. Length times width. 18 inches times 18 inches. And 18 times 18 equals 324 inches squared. But again, that would be calculating all of this. We've got to get rid of the size of that center circle. So we got to figure out what the area of the circle is, and then we'll subtract that from whatever the square is. So the area of the circle equals pi times radius squared. If our diameter is 6, we know our radius is just half of that. So we're going to go pi. Our radius is 3, and we're squaring. Order of operations are super important at this point. Please excuse my dear Aunt Sally. We have to do parentheses first, which we don't have any. Then we have to do exponents. So a lot of people will make a mistake here, and what they'll do is they'll first multiply pi and 3 together, and whatever they get, they'll square. That is wrong. Don't do that. You've got to follow, please excuse my dear Aunt Sally. So the first thing we're going to do is this. 3 squared means 3 times 3, which is 9. So now we have pi times 9. So in my calculator, pi, 3.14, times 9, gives me 28.26 inches squared. So it might be easier to write it like this, inches squared. And so now I've got to take my total square and I've got to subtract out that circle. So I'm going 324 inches squared minus 28.26 inches squared. And I'm getting 295.74 inches squared. So we found the area of both of our pieces, so now we've got to add them together. And then remember, they always want them to be in square feet because that's how we calculate the weight. So I need to figure out the total area. So I'm going to take 376.8 plus 295.74. And so my total area, I'm going to come over here and write it, is 672.54, but this is inches squared. If you have a construction calculator, super easy. You just hit convert, feet. If you don't, remember that to convert to feet squared, you would divide by 12 twice. So divide by 12, and I'm getting that in square feet, we are about 4.67 square feet. And so that is our area. It's telling us up above, right here, that a lead sheet is 3 pounds per square foot. I have 4.67 square feet times 3 pounds per square feet. So 4.67 times 3 equals about 14.01 pounds. This is our weight. Again, there are examples in the book you can refer to, but here's just some video. Please email me if you have any other questions. Thanks and goodbye.